here. So we're just going to start with number 1, which we have done ones like this before. So we would have log of 5x equals log of 2x plus 9. And so on these problems, when we have a log on both sides, everything's on the inside of the log. What can we do with those logs? Just cancel those out. 5x is going to equal 2x plus 9. And so then you just have a simple two-step equation to solve. You're going to subtract that 2x. So we've got 3x equal to 9. And we could divide both sides by 3. So x equals 3. You do on these want to look back up here and make sure if you do plug in that 3, that it's not going to give you a negative inside of the log. In this case, that 3 is fine. It's not going to give you any trouble. Okay. Several of those other first ones are like that. But then when we get down to number 6, we have a different type of problem. We have 2 log base 7 of negative 2r equal to 0. Now, this time we have this 2 right here that's not inside of the log. We also don't have logs on both sides. So we want to try to get the log by itself so that we can get rid of it. You've got a couple options on what you can do. You can either bring the 2 in as a square, or you can divide both sides by 2. Let me look back at my notes real quick though, because I'm thinking of that. For this. I think we're going to go back. Alright, so the easiest thing, if possible, is usually just to divide that off instead of doing exponents. We'll see some where we have to do exponents, but we're not going to have to do that here. So we got log base 7 of negative 2r equals 0. And then we are going to do 7 to that power to get rid of our log over here on this side. So we have negative 2r equals 7 to the 0, or anything to the 0 equals 1. And then we just divide off that negative 2. So r is going to equal negative 1/2. Now, our answer is negative, but if I plug it back in, I have negative 2 times negative 1/2, which gives me a positive, so it's still okay that this is the answer. So this is correct. Okay, questions? All right, let's look at number 10. Actually, let's do 9. I want to do 9 because I don't like the notation they use with this sometimes. So you have log negative m plus 2 equals 4. So on this worksheet, we've got this negative m right here. I really wish they would have put parentheses around that, because it looks like it's log minus m, but it can't be log minus m because you can't have just a log that you're not taking the log of anything. So there has to be something behind that log that you're taking the log of, which in this case is that negative m. If it were on something I was creating, I would put the parentheses there just so you know that it's there. So if it looks something like that, whatever's directly behind the log has to go with the log, because you got to have something that goes there with it. So for this one, you got to get that log by itself first. So you would subtract the 2. And so you would have log of negative m equals 2. Then, Noelle, what's the base for this log? Is it 10 since we do not have one? So we're going to do 10 to that power on both sides. So we'll have negative m equals 100. And then when we divide by our negative, we'll end up with m equals negative 100. Again, that's a negative answer, but when I plug it back into the original problem, you're going to have negative times negative, which gives you positive, so it works for that one. Okay, questions? All right, for number 12, we've got log base 9 of negative 11 x plus 2 equals log base 9 of x squared plus 30. And so, in this case, this is a lot like the first ones because we can just drop the logs, but it has a square, so solving it after that is a little bit different. What do we do whenever we've got to solve something that has an x and an x squared? We're going to factor. And before we can factor, we have to everything to one side. So we're going to move everything. I'm going to move it over here. We'll subtract this 2 from that 30. I'm going to make that 11 positive, so I'll get x squared plus 11x plus 28. And then I'm going to factor this. We'll have x and x. What numbers could I use to get 28? But 11 in the middle, we'll get 4 and 7. So I will get x equals negative 4 and x equals negative 7. I do need to check to make sure that I'm not getting negatives here inside of the parentheses. But if I do negative 11 times negative 4 or negative 7, that gives me a positive number. So it's going to be okay over here. When I square a negative, I also get a positive. So both of these are okay. Yes, you got it. Yeah, go ahead. Mm-hmm. All right, questions? All right. Let's look on the back side now, and let's do number 15. So for number 15, we've got log of x plus log of 8 equals 2. So in this case, I have logs on this side. I do not have a log on the other side. But these two logs are separate from each other. So I cannot just like drop the logs from the beginning. Any ideas on what I could do here? Perfect. So here's where we'll start bringing in some of those log properties that we were doing on Friday. So log x plus log 8 can be written as log of 8x. We can combine them using those properties of logs that tell us if we got two things added, we can put them together with multiplication. Which is great because now I've only got one single logarithm and I can solve this equation. So, Reese, what is my base on that log? Okay, so how do I get rid of the log? Good, so I'll do 10 to that power. And so that'll just give me 8x equals 100. And then I'm going to divide both sides by 8, which will not go evenly. The answer key for this gives everything in fractions, so that's fine. It's also okay with me if you do decimals there, but it gives everything in fractions, so they give, divide everything by 4, they give 25 over 2. But 12.5 is also fine. Okay, questions? Let's look at number 20. For 20, you've got log base 9 of x plus 6 minus log base 9 of x equals log base 9 of 2. So, it might be tempting here just to drop the logs because they're all the same, but you cannot do that because of this minus sign right here between the two logs. So we're going to have to do like we did on the last problem. We're going to have to combine those two logs. Grace, how could we combine those two logs if we've got a minus sign in between them? Good. So we will have log base 9 of x plus 6 over x. And that will equal log base 9 of 2. And now that we have just a single log on each side, we can do 9 to the power on both sides. It just cancels out. You can drop the logs. So you got x plus 6 over x equals 2. All right, how do we solve that? They don't cancel. If we did try to cancel these here, we could divide here, but we would have to divide x by x, which would give me 1. We'd also have to divide the 6 by x there. So we cannot just cancel those two right there. We are going to need to multiply, but it's not going to be, we're not going to multiply really that x plus 6. So the problem is we got this x down here in the bottom, and you can't do anything. You cannot solve for a variable if it is in the denominator of a fraction. So if I want to get that out of the denominator of the fraction, I could do that by multiplying by x over here, because that'd be like x over 1, and now those would cancel. And I would have to also multiply by x over here. Or the other way you can think about it is you can put this over 1, it's like you're cross multiplying. So you got x plus 6 equals 2x. So whatever you have in that denominator of the fraction, If you multiply both sides by that denominator, it'll get it out of the denominator so you don't have to deal with it anymore. And so then you just have a simple equation to solve. So you could just subtract that x, 6 equals x. All right, questions? All right. Let's do number 23. 23. So for 23, we've got natural log of 2 minus natural log of 3x plus 2 is going to equal 1. So in this case, I've got subtraction. I'm going to need to combine those using division. So it's going to be natural log of 2 over 3x plus 2 equals 1. Now, I cannot drop logs here because I don't have logs on both sides. So how do I get rid of this natural log here? What do you think, Noel? E. So it's going to be e to that power on both sides. So I've got 2 over 3x plus 2 equals e. Now, I'm going to do this the first time, and I'm not going to use the calculator, mostly because the answer key for this gives the answer of this is 2 minus 2e over 3e. Like, it doesn't give you a decimal answer. So I want you to know where that comes from. Then I'm going to go back and I'm going to do it again, and we will use the calculator so you can see the difference there, but they're both the same. So, so this is like the last problem. I've got all this stuff in the denominator. I can't do anything with it while it's in the denominator. So I need to get it out of the denominator. So to do that, I would multiply both sides by 3x plus 2. Make sure you put some parentheses around them whenever you do that. And sometimes it's a little hard for students to see why, but this cancels on the left side because this is like 3x plus 2 over 1. So you have a 3x plus 2 on top and bottom, and they cancel each other out. Which is what you wanted to happen. You wanted to get rid of that 3x plus 2 on that left-hand side. So we've got 2 equals, I'm going to go ahead and distribute my e. So I've got 3ex plus 2e. Now, sometimes it gets confusing with this whenever you got what appears to be 2 variables and knowing how to solve this from here, but we really don't have 2 variables because e is not really a variable. A variable is something that changes. It's an unknown constant that can change. E is a constant number, right? So it's just a letter. In ways, it's a variable because it's a letter we use to represent a number, but it represents the same number all the time, right? We're not solving for e. E is a number. We are solving for this x. 6 right here. So, Actually, I think I'm going to use the calculator first. I think the calculator might help you a little bit. So, let's use the calculator here. So, one way that you can do this is you can just go ahead and do 3 times e, which is going to give you this. So it's going to be 2 equals 8.1548x plus, keep that number in your calculator, and then you could do 2e. So you get the 5.4365, and so on. So it's a little bit easier to see with the numbers in there. You just need to subtract this number. So 2 minus, remember I showed you guys that second negative key is going to give you the answer from the line above. So we're getting here negative 3.4365 equals 8.1548x, and then we're going to divide by that 8.1548. And so we take this number and divide. Some of you guys have the better calculators where you can go back up and do that. So I get negative 0.421. Now, our answer key is not going to give the answer like that. Okay? So I'm going to go back and show you what they do. I prefer to do it the second way because all those decimals are so much rounding. They're trying to keep all those numbers in their calculator and all of that stuff. So I prefer to do it the second way, but it is a little tougher to visualize if that variable messes you up. So I do the same thing. I just don't type it in the calculator the same or until the end. So I do minus 2e. From both sides, so I get 2 minus 2e equals 3e times x, and then again I'm trying to solve for that x there, so I'm going to divide by 3e. So the answer key gives the answer is 2 minus 2e over 3e. I think that's a lot quicker because you don't have to type all that stuff in the calculator. But some students have a hard time knowing what to do if you leave that e in there. But if you type it in, 2 minus 2e divided by 3e, you're going to get that same number that we got over here. Yeah, both of those answers are fine. In fact, we are going to have a quiz tomorrow, and on that quiz, I actually want you to give me this decimal answer because it's going to be on Canvas, and you're going to have to type in the answer, and I can't really have you do that if you're doing 2 minus 2e over 3e. So tomorrow, you can do it either way. You can leave the e's until the end and then type it into the calculator, or you can change it from the beginning and do it that way. You'll get the same answer, but you will have to type your answer in as a decimal for those. I just want the answer keys here. Don't do that, so I want you to see both. Okay, questions? All right, so that covers, I think, more or less pretty much everything you're going to need to see for your assignments tonight. I think we've kind of done one of each type of question. Your assignment is going to be to finish up this worksheet. but we are also going to play a game. So I need to get things set up for our game that we are going to play. And then, so you guys go ahead and start working on this while I get all of that set up. And 2.